Hey everyone, my name is Karthik. I'm a grad student from Electrical Engineering Department. Today I would like to discuss about the challenge project which is selected, Wildfire Risk Prediction using Bayesian inference in Poisson regression. So wildfires are one of the biggest side effects of the climate change. And since I moved from the state of Massachusetts to California, I've been noticing a lot of wildfires happening in California and also the parts of Oregon as well as in Washington. And the very recent wildfires in the state of California that happened in LA was one more motivating factor for me to just take on this project. And I always had this intuition that wildfires always had a correlation between the amount of precipitation received for the particular area or the region. So we collected the dataset for this particular project using ChatGPT's deep search from the websites of the California, Oregon, and Washington, and we tried to kind of have a side-by-side comparison of the precipitation in inches versus the number of wildfires. We use Bayesian inference for the wildfire risk prediction, as well as we also use the Poisson regression to estimate the number of wildfires which might happen. And Poisson regression here is an kind of extension of concept to the Poisson distribution. For data processing, we used pandas and data frames to be able to clean the data and normalize the data and such that we can have the data in a proper format. And as you can see, we also used Folium and GeoPandas to be able to visualize the wildfire risk for the US map with respect to color coding of high, low, moderate, will be followed by red, green, and yellow. Apart from this, we also kind of inculcate the real-time fire alerts into the app on which the code is deployed. User can actually see what's the real-time alerts apart from the estimated wildfire risk for imaginary precipitation value. So results, you can see the results onto the Streamlit app, which we actually deployed. It also uses a GIS mapping to be able to show the state with respect to color coding and also the number of wildfires predicted. So here's the GitHub code. So for the project, I initially started with the data set, which is this one. And here, as you can see, the data when we got from the data set, it's actually pretty messy and it's not well normalized. So we clean the code using the data cleaning Python script. And once we able to clean the Python script, it is actually in a good format in terms of year, precipitation inches, wildfires for the respective states. On top of this, we try to build the Bayesian inference, which actually gives the validation of the estimated probability of wildfires. And once we got some confidence, I was able to do some research in Reddit as well as in some LLMs and got the confidence that I can deploy the code onto the Snowflake Cloud via Streamlit app, and where we can actually see the real-time wildfire risk prediction. So here is the app real time, and I selected the state as California, and I'm going to enter the number of inches of rain as 29. So for 29, it's predicted as low risk for state of California, and the number of wildfires predicted is 8657. And the probability of high wildfire for California for 29 inches is given as 15.19%. And this is the real-time data which predicts high wildfire risk for LA. But this 29 inches might not be a low risk, but for state of Oregon, 29 inches is considered as high risk. And if we go above, maybe if we go 35, this is predicted as a low wildfire risk for state of Oregon. So I'm going to do 39, and I think 39 inches is considered as a low wildfire risk for Oregon, and 39 might not be a low wildfire risk for state of Washington. So as you can see, 39 inches is considered as a moderate wildfire risk for Washington. So as you can see from 3 different states, the historical data, which actually gives you what's the risk of wildfires for a particular state, depending on the amount of inches. A given amount of rainfall might not be a low risk might be a low risk for one state, but it might not be a low risk for other states. So this actually helps to evaluate the wildfire risk for independent states. So we rely on the historical data for this. So to conclude, and for future, I'm thinking to extend this project by using other variables like wind, temperature, and amount of fuel available for the wildfires to grow more and more. So yeah, I might use machine learning and logistic regression in future to extend this project. Thanks everyone who is watching this video, and thanks to Professor Chris and the TAs. Thank you so much.